This domain question really is kind of a whole can of worms, and I might not be giving you the whole story when I explain what I'm about to explain, but I'll say this much. You do want to consider the domain of all the functions involved, and when you're looking at an equation, the best way to know about the domain is just to remember there's two rules you can't break. No dividing by zero, not allowed, and no square rooting negatives. That's also not allowed. So if you have problems that are dividing things or square rooting things, you've got to be careful. This function, there's no dividing and there's no square rooting, so this guy's domain's all real numbers, so it's not such a big deal. But this fella here, that's got a square root in it, and you cannot square root negative numbers. Saying something's not negative is the same thing as saying it's more than or equal to 0. So just like we did at the beginning of the previous chapter, I think chapter 9, you want to take what's under that square root symbol and guarantee that it's not negative, which is the same thing as saying that that's got to be at least 0, greater than or equal to 0. And if x minus 6 is more than or equal to 0, then of course x is more than or equal to 6. That is this function's domain, x more than or equal to 6. So the domain of the composition of two functions is the intersection of these two domains, like wherever they overlap, which in short becomes just this more restricted situation over here. So our domain ends up being x is more than or equal to 6, which is funny because if you look at the answer to the problem, g of h of x, it was just equal to like x minus 3, I think, or something like that. But it's only good if the x value is more than 6, even though this itself has no problems at all, because this one into making it, we can only let x's be more than or equal to 6. Strange, but true.